One very important thing about transformations that you want to think of is actually applying more than one transformation to any given function. This is really where their power comes into play. So rather than just looking at a single stretch or a single shift, go ahead and apply more than one of these together. Some of the key things that we're going to be looking out for as we apply more than one transformation is where they're located. They'll either be on the outside or the inside. We'll be looking at addition and subtraction for our shifts, multiplication for our stretches and shrinks, and negative signs will help us recognize any reflections that might be present. Also keep in mind that anything we do to the outside of our function will affect it in the vertical direction, or we'll start messing around with those y values. If we have an inside transformation, this will affect it in the horizontal direction, and then we'll start messing around with the x values. Let's get to our examples and see how we can start applying these transformations. So in this first one, I have a graph of a given function, and I'm just going to call this h of x. We're going to use this as our parent function, and then see if we can graph 2 multiplied by h of 5 minus x. So this new function is taking our h function and applying those transformations. Let's first recognize some key points on our original function. So it looks like it has one point right here at negative 6, 3. Looks like another one up here at negative 4, 5. Here's one at negative 2, 3. Here's one at 1, 0. So we're going to keep track of those and find out where they end up. Alright, now let's write down our transformations, starting with the ones on the inside and working our way out. So if I was to plug in a number for x, the very first thing that I have to apply to it is actually the negative sign. So that will be our first transformation. Remember, negatives signify a reflection. Since this is on the inside, this will reflect it over the y-axis. Alright, not too bad. Moving out from there, I can see that the next thing that happens to it is actually this 5. So we'll be adding 5 on the inside. When we add 5 on the inside, this will make it go left 5. Alright, looks like we have one more transformation. This 2 is being multiplied on the outside. So this will stretch it by a factor of 2. And since it's on the outside, this will stretch it vertically. Alright. So let's grab our key points here, see where they've ended up. I'm first going to figure out what happens when I reflect all of them over the y-axis. Let's see, so this one will be reflected over the y-axis, end up here. This guy's still at 0. This one will end up over at 2. This one was at negative 4. It will now be at positive 4. This one's at negative 6. Now it's going to be at positive 6. So if you want to lightly think of where this thing is, you got your nice straight line here, and there's that curved part. Alright, now this entire shape is going to be moved to the left 5 units. So look at these new points. I think of moving to the left. 1, 2, 3, 4, 5. So there's the new one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here's our curved pieces. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Perfect. So there's where we have it now. There's our curved guy. And now just one more transformation to do. This will stretch it vertically by 2. So think of taking all of those y values, multiplying them by 2, so we can figure out where they're at. So this y value right now is at 0. 0 multiplied by 2 is still 0, so this spot will end up in the same place. This y value right here is at 3, Now if I multiply that by 2, it's going to end up at 6. So my initial straight part here now is like this, been stretched. Alright, other key points. This guy's at 5. Multiplied by 2 will be at 10. This one's at 3 multiplied by 2 is at 6. So we still have our little curved piece, but now it's been stretched out. Alright, so in green, this represents our new function, our 2 multiplied by h of the quantity 5 minus x. Alright, now in some examples, they may not give you the graph of the original function. This is something that you should know or end up graphing initially. So let's do this example. Here I want to graph negative the quantity 1/3 x cubed minus 2. Our parent function in this case will be our cubed function. So think of x cubed. Let's start off by graphing that. I know it goes through 0, 0, 1, 1. Let's see, 2 cubed would be 8. And then 3 cubed is way off the chart. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8. So the original function has this nice S shape to it. Looks something like that. Mark that out as x cubed. Perfect. Alright, some key points that I want to keep track of here. Let's see, I know it goes through 0, 0, 1, 1, and this 2, 8. Those are probably some good spots to keep track of. Alright, now let's write down what we're going to do to this thing. Starting with the very inside, I can see the first thing that happens is that it is multiplied by 1/3. Since it's on the inside, this will stretch it. This will stretch it by a factor of 3 horizontally. Alright, moving out from there. Now I run into this negative. The negative's on the outside. So this will reflect over our x-axis. Alright, looks like we have one last transformation, the minus 2. So we'll take our entire graph and we'll just go down 2. Perfect. Alright, now it's time to keep track of our points, see where they've ended up. Let's first start off by stretching it horizontally by a factor of 3. So imagine taking all of their x values, multiplied by 3. This x value is 0, multiplied by 3, still at 0. This x value is 1, multiplied by 3, puts it at 3. And this x value is 2, 2 multiplied by 3, now we're way out here at 6. Alright, doing the same thing to the other side. Let's see, so I have negative 1 multiplied by 3, it's at negative 3 now. Negative 2 multiplied by 3, now out here at negative 6. So that first transformation, we can see that's just taking our entire cubic and really stretching it horizontally. So I'm just going to draw a faint line here so we can do a few more. So it's stretched out. Now it says take this and reflect it over the x-axis. So all of our points end up on the other side of the x-axis of where they used to be. So this guy's at 0, hasn't changed. But this one's now going to get flipped over, now at negative 1. This guy gets flipped over, now it's way down here at negative 8. Alright, doing the same thing on the other side to our other points. So this one, let's see, negative 1 up to 1, negative 8, way up here at 8. So after that flip, see we're getting this nice graph now. Again, I'm going to try and just draw this nice and faint. Okay. So 2 down, 1 more to go, and this will be our final one. So working with this nice S shape, everything will now go down 2 units. Alright, I'm going to start at this point. So down 2, right there. Down 2, right there. Down 2. Down 2. And down 2. So connecting these points, we'll now have an idea of where our final graph lays. There's that much of it. Through our points, through our other points, through these last guys, and off our chart. There we go. So remember that this red line was our parent function of x cubed, and this green line represents our new function, negative the quantity 1/3 x cubed minus 2.